Now, we would like to know what is the necessity of such a theorem called Green's theorem. Okay, so in order to understand the necessity, I prefer to discuss this problem, this one. Okay. The same problem was also solved in the line integral lesson file. This problem. You see this problem, this one. You see, you are requested to complete such a line integral, this one, okay, where along the line, along the edge of this triangular, edge of this triangle, okay, along the lines of this triangle. So here is horizontal line, here is the vertical line, here is the diagonal line of this right angle triangle, OAB. Now, if you want to know the line integral of along these triangular edges, so how do you complete this line integral? You have to complete this line integral. We need to know the knowledge about this horizontal line connecting 2 points, origin and the A10. We need to know also the knowledge about the C2 line as well as C3 line. That means তোমাকে line integral করতে হবে C1, C2, C3 along these three lines independently. Right? Now, doing this process of solving the line integral along these three edges, right, is little bit lengthy process and it takes a long time, in other words, to complete this line integral. However, one good thing হচ্ছে যে তুমি একটা পয়েন্ট থেকে জার্নি স্টার্ট করে আবার সেই পয়েন্টে ব্যাক করছো। Okay, you can return to the same point. That means such C1, C2, C3 construct a triangular region, closed triangular region. Okay, so if the triangular region becomes closed, right? I mean, if a region becomes closed for multiple connected edges, okay, এটা কোয়াড্রিলেটারাল হতে পারে, এটা পেন্টাগন হতে পারে, হেক্সাগন হতে পারে, হেপ্টাগন হতে পারে, রাইট? সো যদি হেপ্টাগন হয়, for an heptagon, for a pentagon we have 5 edges, for an heptagon we have 7 edges. এখন তোমাকে যদি ইন্টিগ্রেশন করতে বলা হয় along the heptagon, right, then you need to complete line integration for 7 edges independently and taking the sum of all of them, then you will get the line integral. Okay, so here is the big challenge. যে আমরা যদি প্রত্যেকটা লাইন, if we have many lines, so for each line যদি আমরা একটা করে লাইন ডিল করি, it will be very lengthy process হয়ে যাবে. Okay, now to overcome this situation, we need another process of evaluating a line integral which has been provided by famous mathematician Green's, and we call it after his name Green's theorem. Okay, so Green's theorem will be applied for what? Green's theorem will be applied for simply connected domain, closed domain এর জন্য এটা অ্যাপ্লাই হবে। Here is the Green theorem. This is the Green's theorem. So what is the statement of the Green's theorem? To look at this statement, the statement tells us about, you're familiar with this formula, fxy dx plus gxy di, right? So if you look at this formula, Green's theorem বলছে this can be evaluated by taking a double integration of del g del x minus del f del y into dA. And double integration should be taken on what? Double integration should be taken on the space that is surrounded by the line C. Okay. So then doing a single line integral, now it's become easier to handle just a double integral here. Okay. And this help to complete the line integral in a short time. Now you see, for the same problem that we have discussed in the last lesson, that the same triangle, and same expression of line integral. However, C is now considered as a closed triangular region, closed triangular path. Okay. And therefore, C1, C2, C3, from these line elements, C1, C2, C3, we see that along C1, only x is varying, along C2 only y is varying, but along C3 both x and y is varying using a relationship y equal to 2x. If they come to 0, 0, equal 1, 2, so it is y equal to 2x. Okay. So now this triangular region covers, within this triangular regions, y is varying from 0 to 2x, x is varying from 0 to 1. So once you complete this double integration formula আমাদের গ্রিনস থিওরাম থেকে আমরা পাচ্ছি del g del x minus del f del y. So what is g and x? G is the y component here, y এর coefficient, and f হচ্ছে আমাদের এখানে dx এর coefficient. So f of xy is x square y, g of xy is only x. Okay. So then according to the Green's theorem, double integration should be taken on del g del x minus del f del y. Come on. And doing so, del g del x, what is g? G is x, so del g del x is only 1. Del g del x minus del f del y. So del g del x হচ্ছে 1 আর del f হচ্ছে আমাদের x square y. x square কে যদি y square করি, that will be only x square here. And you limit here from x equal to 0 to 2x. So the y equal to 0 to 2x and x equal to 0 to 1. So এই ইন্টিগ্রেশনটা কমপ্লিট করলে আমরা রেজাল্টটা পেয়ে যাব 1/2. Very easily we can find it out. Okay. So that is the strength of Green's theorem. Now let us move on directly to the exercise where we will find out many more problems to solve Green's theorem. এখানে প্রত্যেকটা প্রবলেমে আমাদের exercise 15.4 এখানে প্রত্যেকটা প্রবলেমে আমাদের Green's theorem দিয়ে সলভ করতে হবে। So let me now open the board. Okay, we're now going to solve a problem. The first one, which also follows the similar pattern of the last example that we have shown, we have displayed, discussed in the from the lesson. Okay, so you are ready to solve a problem here. So our first problem is given in here. Use Green's theorem. Use Green's theorem to evaluate the line integral. This line integral number 3. In each exercise, assume that the curve C is oriented counterclockwise. So আমরা এখানে C টাকে counterclockwise consider করি. Let us first consider basically the Green's theorem. Let us everyone write the Green's theorem here. Green's theorem. This should be keep in mind. Green's theorem is if we have such a closed domain which is defined by C, then function of x, y, dx plus function of x dy should be, since C is like a circular by any kind of closed domain, this should be equivalent to R del G del x minus del G. Should become first del G del x minus del y into dy dx, but dx dy whatever you like. How R is defined? R is basically defined by this closed space. Okay, and one thing is important. এখানে আমরা closed space কে C, last question C দেখিয়েছি, that was the line integral, right? In this class we are also considering C, but this is the line integral also closed loop. That's why আমরা এখানে একটা closed loop দিয়ে দিই. That's why realize করতে পারছি না. Different color দিই. This one. এখানে একটা symbol দিতে. This symbol indicates the line integral is taking only on this line, because closed line, closed loop. And another thing is also important, that this C should never be like the C in here. should never be like সিটা কখনো এরকম হতে পারবে না, এরকম হতে পারবে না। সি should be no entanglement. That's why we call it simply connected domain. Simply connected space of domain. Okay. এখন এবার আমরা আসবো এক্সারসাইজ 15.4. So 15.4 number 3. Okay, so let us now solve number 3 here. Okay, so sorry if you are receiving any network issues, you're facing any network issues, so you'll just try to write down what is written in the whiteboard. So our first problem যদি আমরা দেখি, first problem was let us write down the formula problem. Look at here, আমরা এখানে বলেছিলাম যে the movement along the circle should be anti-clockwise, and this is what we have chosen here according to the question. We have 3xy dx plus 2xy dy. 3xy dx plus 2xy dy. And which is bounded by x minus 2, where c is bounded by x equals to minus 2, x equals to 4, x equals to 4, x equals to y equals to 1, y equals to 2, y equals to 1, y equals to 2. So if we follow these 4 lines, we'll get here x equals to minus 2 is here, x equals to minus 2, x equals to plus 4, y equals to 1, y equals to 2. So we are going to mark up Puri. That indicates this is one point, here is another point, there is this point, here is this point. That means the path should follow this track. Okay, here it is minus 2, it is plus 4, it is 1. Oh. So now, where is our R? Our R is basically this whole space is our. So that means if we denote it by R, so R is defined here by X. X will be defined by minus 2 to 4, y will be defined here minus 2 to 4, and y will be defined here 1 to 2. Therefore, according to the Green's theorem, you can write it by this form. Here you see this is gx, sorry, not gx, but this is, I did a simple mistake in here. The g is a function of xy হবে. একটু correction করে দিই। This is g a function of xy, and here is f is a function of xy. Okay. So according to the Green's theorem will be applicable when this C encloses a closed region. Okay. Only that purpose we can apply Green's theorem, and this condition is satisfied in here. So what is g of xy here? 2xy. So del x of 2xy. What is function of xy? 3xy. Del f del y into 3 of xy. Yes. Into dA. Del x 2xy, that indicates 2y minus y, that will indicate 3x dy dA. So what will be the limit for y? Y আমরা বলছি 1 to 2. Y হচ্ছে আমাদের 1 to 2, x হচ্ছে আমাদের -2 থেকে 4. So you integrate this part, -2 to 4. If you complete this integration, that would be y square minus 3xy. Lower limit 1, upper limit 2. Yes. Now complete this integration and let me know your answer. যেটা কমপ্লিট করে আমাকে অ্যান্সারটা বলো সবাই।
দেখ 0 আছে।
What answer are you getting here? 0?
Yes, sir.
Check.
স্যার 6 আসে।
এখানে y স্কয়ার কমপ্লিট করলে এটা
স্যার আমার -12 এসেছে।
-1 -3x into 2 minus 1. Yes. So I am getting 0 here. Everyone please check this calculation. If you find any mistake, you can ask me. Result check করে দেখো. If there is anything wrong, you can ask me.
ঠিক আছে স্যার।
So I believe you have got the same answer as I have gotten here, 0, right? Okay. So now the 0 indicates, last class I'm bolchilam, if it is a work done process, so the 0 means let's say no work is done. If we return from one point to the another point, that means the system is conservative. If 0 is become your, if 0 becomes your result, then the system will be conservative. If the 0 doesn't return, the system will be non-conservative. Okay. So in this case, I'm a 0 page. That means under this field, the work process, if we start from a point A and coming back to the same point, that will be 0. Okay. Let us solve another one. Can I ask you now to solve number 6? Number 6 to solve করতে পারবে? আর 6 এর আগে 4 টা করো। 4 6 আমার পরে করছি। এবার to solve number 4. Where C is the circle, x square plus y square equals to 9. Everyone please give it a try.
স্যার এটা কি পোলার কোঅর্ডিনেটস দিয়ে করতে হবে?
তো এটা আমাদের পোলার কোঅর্ডিনেট করতে হবে, রাইট? ইউ গেট দ্য রাইট পয়েন্ট। তার কারণ হচ্ছে এটা যদি পোলার কোঅর্ডিনেট না করি, টেক a long calculation. This will be taken a long calculation. সেজন্য এটাকে আমাদের পোলার কোঅর্ডিনেটে সলভ করতে হবে। ওকে, যারা পেরেছো গুড, যারা পারো নাই everyone please have a look at this solution. I see the problem here. You are for number 4, right? Four, which is C. X square minus y square dx square minus y square dx plus x dy. X dy. Plus y square dx plus x dy. Where C is the circle, x square plus y square. How C is defined here? X square plus y square equals to 9. Therefore, transforming this line integral to this double integral using the formula of Green's theorem. So Green's theorem tells us dy যে coefficient থাকবে, that should be divisible by x minus x এর যে dx যে coefficient থাকবে, that should be divisible by 1. Here it is dy Okay, so here now, if we look at the region R indicates a circle. Next one. Circle of radius 3. And this circle is rotating. I mean, this circle, you're moving along the circle in a counterclockwise direction. Therefore, this is 1 plus 2y, right? Or dy dx. Now, this r is what? This r is the circular region. R. That indicates we are suggested to complete this integration in polar coordinates. And to do so, 1 plus 2y means 2r. You know, in polar coordinates, x equals to r cos theta, y equals to r sin theta, and dy dx equals to r dr d theta. 1 plus 2r sin theta. This is r. Here is dr. Here is d theta. So how r is changing? 0 to 3. Theta is changing 0 to 2 pi. 0 to 3. 0 to 2 pi. So outer integration is 0 to 2 pi. Lower integration complete. Inner integration complete. That would be 1 into r plus r square sin theta 0 to 3 d theta. So 3 is 3 plus 3 square 9 sin theta 0 to 2 pi d theta. Finally, you can have 3 theta minus 9 cos theta 0 to 2 pi. So 3 is
স্যার
2 pi. Yes, sir?
স্যার এখানে বাইরে একটা আর আছে না, ওটা সহ ইন্টিগ্রেটেড হবে না?
হ্যাঁ, শেষ হয়েছে তো, যে আর কে 1 দিয়ে মাল্টিপ্লাই করলে আর হবে, ও সরি, এটা হবে আর স্কয়ার বাই 2, এখানে হবে আর স্কয়ার বাই 2, 2 ইনটু আর কিউব বাই 3. রেজাল্টটা চেঞ্জ হয়ে যাবে. We'll see a different result here. There is 9 by 2 plus 2 by 3, 18 হবে. Sin theta d theta. So then 9 by 2 theta minus 18 cos theta 0 to 2 pi. So 9 by 2 into 2 pi, 2 pi, 2 pi, sorry, 2 pi minus 18 cos theta. So, cos 2 pi 1 cos 0 1, this is out, so 2 out, 9 pi. I believe everyone has got the same answer. Is it okay?
Yes, sir.
আমরা একটা problem solve করব. Here is the problem. So likewise before, without thinking twice, we will apply the Green's theorem because this represents what? Who can tell me?
The
This
circle টা কি
equation represents what?
y
Of
অক্ষে
course, a circle. Where is the center?
I think y অক্ষের নিচে।
Sorry?
স্যার -1 এ হবে মেবি।
Sir, 0 minus 1.
0 minus 1, right? 0 minus 1 is here. So এখানে একটা সার্কেল আমরা ড্রয়িং করে ফেলি। Okay, so this point is -2, sorry, -2. Here is -1. Okay, so now del x of this 10x minus del y of y 10 square x. dA. dA. 10x is sec square x, and there is 10 square x, right? 10 square x is r 1 dA. Okay. So what this again now? Can I ask you what this integral represent to us? What this integral represent to us?
পোলার কোঅর্ডিনেটস।
Equals to 1. This represent what? The integral টা কি represent করছে?
Area.
Area. Area of what? Area of this circle. So, what do you expect the answer here? No, you should have answered me by this time. The answer কি হবে?
Sir, pi.
Right, pi. Pi into r square. এটা রেডিয়াসটা কত 1, right? Pi into 1 square equals to pi. That's your answer. I mean, once you understand that this integral form represents geometrically an area of a circle, so you can just write the area of that circle. You don't need to proceed the integral process. Okay? ঠিক আছে? So এখান থেকে আমরা 3 করেছি, 4 করেছি, 6 করেছি. So I'd like to give you some homework. 7 and 4 is same. Do not need it. Number 8. Number 8 টা করবে. Write down the number for your homework. Number 8.